This lesson is on box plots, sometimes called box and whisker plots. I am going to use this dollar bill to help demonstrate how easy box plots really are. I am using a fake dollar bill because it's going to require me to cut this bill up, and I am not going to risk going back to prison cutting real money. I just wouldn't make it in there. I would just get beat up. So we're going to use this fake dollar bill to demonstrate how easy box plots are. So the total value of this is $1. Now, if I cut this exactly in half, just like that, then I've got two halves. What is each side worth? This side is now worth 50 cents. This side is worth 50 cents. So 50% of my money is here. 50% is here. Altogether, I had 100% of a dollar. Now I have 50% and 50%. What happens if I cut each of these pieces exactly in half? Well, one piece falls down. Then I have 25% and 25%. It's like having a quarter and another quarter to make up the 50 cents. Now, what if I were to do that to the other piece here, this 50 cents? So it's almost like a 50-cent piece. And then I cut this in half. Then I have the equivalent of 4 quarters. 25, 25, 25, and 25. That's how easy a box plot is. That's all it is to it. Okay, well, maybe not all there is to it. I may exaggerate that a little bit, but not much. For all intents and purposes, if you understood this, you'll probably understand what a box plot is. So we're going to do that right now. I asked my students to try a little experiment in which they were trying to see how many drops of water from an eyedropper that they could fit on the head of a penny before the water burst or fell off of the penny. And this chart here shows all the data that was collected from my students. 16 students responded with their results from the experiment. What I'm going to do is to show you how to create a box plot or a box and whiskers plot from the data that was collected. And I am going to do this with the help of using the poor man's whiteboard or chalkboard, whatever you want to call it. But this is all I have to work with right now. So this is what we're going to use, and I'm going to show you how to take this data that was collected and use it to create a box plot. If you've noticed, I've already placed the data in order from least to greatest, which is step number 1. The next step, step number 2, is to find the median of this group of numbers, this set of numbers. And in order to do so, we're going to start with the lowest and the highest amounts, and we're going to work our way to the center until we find what the median or middle of this data is. If we do it with this particular data, since I have 16 results, we're going to find that 18 and 19 are the last two numbers. So we're going to take those two numbers, we're going to add them together, take that sum and divide it by 2. That's going to give us 18.5. So 18.5 becomes our median for the entire set of data. I am going to cut the cardboard right where the median would be. That's going to separate our data into 2 groups, 2 equal groups, just like with the dollar bill I was showing you. If I cut that dollar bill into 2 equal groups, I've got one side that's half the amount, the other side's the other half. So here I have 2 groups of 50% of our total data. Our next step is to find another median, but this time we want to find the median of one of the either lower half or the upper half of our data. So let's start with the lower half of our data. We need to find the median. I have a 10 and a 15 that are in the middle of that half of data. We're going to add 10 and 15, divide by 2. That's going to give us 12.5. So 12.5 is our median of the lower half of our data. Now what I'm going to do is I'm going to cut this at 12.5. That's going to split our 50% up into 2 equal parts. So now we have 25% of our data, and then the next 25% of our data. Our next step is to split the upper half of our data into 25% sections. So we'll take our upper 50%, find the median, which would be 23.5, because we're going to find that 23 and 24 are the two numbers in the middle. We're going to add them together and divide by 2. That's going to give us 23.5. I'm going to cut the cardboard here at 23.5. Now I have split my upper half 50% of data into 2 equal parts. So now I have what represents 4 25% sections of our 100% or 100% of our data. I hope that you can see how this pertains to me cutting up that dollar bill, that fake dollar bill, into 4 equal sections, each section representing 25% of a dollar. Each of these sections I've just split this data up into represents 25% of all of the data. So it's, in essence, all of this was $1. I just split each section up into 25 cents. What did I obtain? Well, I obtained 3 different medians. I obtained the median of the entire set of data, which was 18.5. Then I obtained the median of the lower half of my numbers, which was 12.5. That is our first quartile. And then if you look at the upper half, that was a median of 23.5. That becomes our third quartile. And also, I don't know if you've noticed, but I cut the lower and the upper sections into smaller strips. A lot of people will refer to these as the whiskers of the box plot. If you notice that the 2 middle sections are larger, this is our box of our box plot. The 2 smaller sections would be considered the whiskers. They stretch out into the minimum data point and the maximum data point. In this case, our minimum data point is 4, and our maximum data point is 27.